short.
Thank you, thank you. I think I ended talking about the difference between population of sample and individual. Population is the entire group, sample is a smaller group, and individual is one person. You know, ideally, you would always talk to the whole population. If I want to know what lunch option do you prefer, is it feasible that I could talk to every high school student and ask them what their favorite lunch option is? Technically, I could. It's doable. Would it be time consuming? Yes, but it's doable. What if I wanted to know what lunch option was preferred for all college students in the United States? Is it feasible that I could talk to every single college student in the United States? No, it's possible, maybe, but it would take a lot of time and money. So most of the time, it's just not reasonable to talk to everybody, or if you're doing a study, that's just too much data, so you have to use a sample. Of course, if the population is small, if I only care about our stats class, you guys are the population, so I could certainly ask all of you. But if I'm worried about a bigger group, then we might have to do a sample. So with that, we talked about descriptive and inferential yesterday. I think these are the next two terms on our handout. Right underneath the population box, it says parameter. And underneath sample, it says statistic. Any number that I collect. So if I said the favorite lunch option in our high school is pizza. Okay. To decide if that is if I'm talking about like a parameter or a statistic, we need a little more information there. So I can say, I asked every student in the high school, and 65% of the students chose pizza. So 65%. I got that number from every student in the high school. So I got it from my population. So that means the 65% is a parameter because it came from the whole population. And that would be descriptive or inferential. Descriptive, because I'm just telling you what I found. But let's say I said, after talking to the senior class, 70% of students in our high school prefer pizza. Okay, I'm worried about everybody in the high school, but did I ask everyone in the high school? I only asked the seniors. I only talked to one group, so I talked to a sample. So my 70% is talking about my sample, so that would be a statistic. Would that be descriptive or inferential? Inferential, because I'm trying to take what the senior said and make it apply to everybody. So that's inferential. So just remember, P's go together and S's go together. Population, parameter, sample, statistic. All right. So now if you flip over to your example slides, I think this is the first example on here. I want to know if each of these are descriptive or inferential. Remember, descriptive just tells us what it is. Inferential, we're trying to make some sort of guess. The average age of 500 surveyed students in your institution is 23 years. Okay, did I talk to all of them? It didn't say otherwise, right? It didn't say I took a smaller group. So am I making some guess, or am I just telling you what I found? Telling us what we found, so that's descriptive. Okay. B. Based on a sample of 10,000 Americans, it is fair to say that 70% of all Americans are overweight. Inferential. I'm trying to apply this to all Americans, but I didn't talk to all Americans. So that's inferential. Trying to make a guess. C. 80% of students in your statistics class dislike true-false questions. I probably should have given a little more information here, because I didn't specifically say who I asked. Would it be reasonable to assume that if I'm talking about our class that I asked all of you? Okay, so let's assume that I asked everyone. So if I asked everyone and I'm telling you 80% dislike them, that's describing what I found, so that's descriptive. Okay, but if I said, based on a sample of 20,000 college students, we may conclude that 80% of all college students dislike true-false questions. That's inferential, because I'm making a guess about all of them, but I didn't talk to all. Do we understand the difference between descriptive and inferential? Let's do a parameter statistic question. Remember, P's go together. So parameter is talking about the entire population, everyone I can care about. Statistic, the S's go together. That is based off a sample, so a smaller group. Okay. So suppose the percentage of all students on your campus who have a job is 84.9%. So I'm talking about this number right here. Is it a parameter or a statistic? Parameter, because it is dealing with the entire population. I only care about students on that college campus, and I told you the number that went with that college campus. Okay, suppose a sample. What is that? You guys? What is that? Yeah, but there's not art in this one. Suppose a sample of 250 students is obtained, and from this sample we find that 86.4% have a job. What would it be there? Statistic. Because that 84 or 86.4% came from my sample. It came from my smaller group. All right. So far, so good? Let's look at this one. CBS News conducted a poll in 2013 and asked, do you favor or oppose raising the minimum wage to $10.10? They surveyed 1,009 adults and found that 706 were in favor of an increase in the minimum wage. CBS reported that 70% of Americans were in favor of the increase, with 3% error and a 95% level of confidence. Okay, a lot of stuff there. A lot of it we don't really know what it means yet. That's okay. My question is, I want to know the research population, sample, and individual. Okay, population is everyone we care about. Who do they care about here?
The country.
Okay, Americans, all Americans or specific ones? Like all age group?
No, just working people.
Well, yeah, so let's just say American adults. Okay, I don't care if Mexico wants us to raise our minimum wage. I don't care if a 12-year-old wants us to. I want to know the voting population. You know, people that vote, what do they think? So we're looking at American adults. The sample. Obviously, I can't talk to every American adult. So what was my sample? 1,009 adults we talked to. Okay, what would an individual be? I don't have this specific, but what is an individual? What does that mean? Yeah, just one person surveyed or one adult. I don't have a list of names or anything. If I did, I could pick a name, but just one of the people that we talked to would be an individual. All right, so right now we're just trying to get a feel for some of the different words that we're hearing, get used to seeing them, kind of picking out what they're talking about. Any questions about those things?
To do a study like that, wouldn't you need a lot more than 1,000
Yes.
adults? Because that seems like a very small number, and it'd be really easy to skew the numbers because you could only ask people that themselves were
You're
high-paid
hitting on
jobs.
so many things.
Or
Yeah,
like-
we're gonna talk about bias, like do you have a good sample or not? How do you pick a good sample? How many do you need? So yes, you summed up a lot of different potential errors there. And that is really one of the key things you should take away from statistics, if nothing else. You really need to question what people say. You know, when you read an article and it has a number in it, it is important. If they only talk to 100 people, then is their information necessarily reliable? You know, if we don't know how they got their sample. So lots of different things can skew the data.
Because if you go ask 1,000 people that work at all the Casey's in the world, it's probably most of them think that they should get a higher.
I mean, if you're talking to people who earn minimum wage, they are all probably going to say raise minimum wage. If you talk to people that get paid based on a salary, they may tell you they don't need to raise minimum wage. So to get a true, like, good data, you need to make sure you're picking people from all the different groups to really understand. But yes, lots of valid points there that we will be talking about. Let's go back to our definition. Do you want me to let you guys write for a minute and then talk about these? Okay. So variable, that's basically what we're collecting information about. It's just some characteristic. And it can be one of two different types, qualitative or quantitative. And it's very easy to determine. If it's dealing with a number, it's most likely quantitative. If it's dealing with some other attribute, it's probably qualitative. So if I ask for hair color, what's that going to be? Qualitative. If I said height, quantitative. One thing to be careful of, like social security number. It's a number, but does it really have a numerical meaning? No. So if the number is just being used like to randomly identify something, so like your jersey number, does it really have a numerical meaning? No. So those kinds of things, even though it's a number, that's still qualitative. But otherwise, something like time, heights, weight, even dollar amounts, those are all quantitative measurements. Now, if it's quantitative, if it's dealing with a number, there are two different types of numbers. There's discrete and continuous. Discrete is something I can count. Okay, so if I say number of students in a class, I can count that. But if I say continuous, that's something that keeps going. So something like weight. Okay, does everything automatically just round, like, it's only accurate to the nearest pound, or tenth of a pound, or hundredth? Couldn't we always get more accurate by adding another decimal place? So when you have all those decimals, that's a continuous number. So before I have you write down those definitions, I just want to take a look at these and see if we can pick out qualitative or quantitative. So I know it's annoying to flip back and forth, but I promise when you need a definition, it's easier to have them all in one spot. A researcher studied factors that affect the eating habits of adults in their mid-30s. Classify the following variables in the study as qualitative or quantitative. Nationality. Number of children. It's a number. Household income the previous year. Quantitative. Income is money, so that's a number. Level of education, like high school degree, associates. Qualitative. The daily intake of whole grains measured in grams per day. Quantitative. All right. You understand the difference between the two? So let's write down the definition for discrete and continuous, and then we'll come back and identify what each of these are, discrete or continuous. So, discrete, both are dealing with numbers. So this is, discrete is basically anything that's countable. If you can count all the values, if you can list them out, that's discrete. Continuous is an infinite number of values. Think decimals. They only apply to the quantitative. Okay, qualitative variables, we can't break them down anymore. But if it's a number, we can decide. So, looking at our examples, from the example we just did, we had these three that we said were quantitative. Would they be discrete or continuous? So, number of children. Discrete. That is countable. Okay, household income the previous year. Discrete. It has decimals, but if we're talking about dollars, we always, or anything with money, we always round it to 2 decimal places, right? So it's not an infinite number of decimal places, so that would still be a discrete number. The daily intake of whole grains measured in grams per day. Because you could measure that to the nearest whole gram, or tenth of a gram, or hundredth of a gram, or thousand. We could have an infinite number of other ways to say. All right, I want to talk about one last thing, and then we're done with this section. I'm stopping for the day. Okay. This is, I guess I do have another example here. I forgot. Do this example, and then I'll do my last topic. I apologize. I tried to take this out of the book instead of retyping it, so it's not the best quality. So in this table, we have different countries, their type of government, life expectancy, and population. So I want to know, in this, first of all, what are the individuals? Variables. That's the information I'm collecting about my individuals. What information did we collect? The government type. What else? So 3 different variables we looked at here. Of those variables, qualitative or quantitative? So government type, what is that? Qualitative. Life expectancy, it tells us in the table, that is measured in years. So that would be okay, population. Quantitative. All right. Looking at those quantitative variables, let's decide if they're discrete or continuous. Life expectancy. Okay, measured in years, but does it have to be round to the nearest year? No, it could be round to the nearest month, or day, or hour, or minute, or second, right? So that would be continuous. What about population? It's measured in millions, but that's just the number of people. You can't have part of a person. So I think they still qualify as a whole person.
What is
without an arm. I think we'll still count them as a person. So. All right, is this okay?